Okay, we're going to continue our continuity discussion on the section 1-2 notes. And so we have three different functions here. And we're going to look at these functions and determine what type of continuity or discontinuity each one has. So in order to do that, we will type those into our calculator, and understanding that parentheses are needed if you're not using the fraction key for both numerator and denominator. We graph this, and we see that the window is not set correctly, so I will go back to standard and we'll graph that again. There we go, only one piece of that graph was showing up, and here we see that we have an infinitely discontinuous function. So I would say that this has an infinite discontinuity, such as our sketch on our third graph above. That is an infinite discontinuity. There is no place for an abrupt stop of either one of these sections in order to jump to the next. Does not appear to have a hole in it, and so we call this an infinite discontinuity. The second graph that we have looks like it might make a parabola, because I can tell just by typing this in that x times this is intercept form of a quadratic. Let's double check to see if I'm right, and there it is. And so we call this a continuous function. We do know that a quadratic makes a parabola, and parabolas would be continuous. So if I was to sketch this, I would be able to draw that in one single motion without lifting up a pencil. So this would be continuous, an example of a continuous function. The third graph we have is a little bit trickier. So we will type this in, and we see that we have x squared minus 4 as the numerator, and we're dividing that by x minus 2 in the denominator. When I go to graph this, it seems like I have a continuous function. It looks very similar to a straight line. I would agree with that. But we always want to double check when this does not look like a linear function, the original one that I plugged in. So that should raise some suspicion in the graph. When I go to my table, I see that I do have an error. Well, a continuous function does not show any error in the table. So therefore, let's evaluate this a little bit closer to see what kind of function we actually have. I can see in the numerator that this can be factored, and any time when you're figuring out continuity, it's always best to be in factored form. So that is a difference of squares. X squared minus 4 factors into x plus 2 times x minus 2, and we divide that all by x minus 2. And I see that I have a factor in the numerator and a factor in the denominator that are identical. Therefore, those can cancel. If I have a factor that cancels, I know that I have a situation that has a hole. So I'm going to look at the x minus 2. That is the one that canceled. And I'm going to say, and just set that equal to 0 to see what x equals. So here x would be 2 to satisfy that factor. Therefore, I know that I have a hole at the location when x is 2. And I can see that on the table as well. When x is 2, I have an error. Therefore, when x is 2, I have a hole in the graph. That graph looked continuous, but it was very suspicious because that was not a linear equation. And by looking at my table, I can see that I do have a hole at x equals 2. So I know that the hole is at x equals 2, but where is the y value? I don't see it here, and so therefore to find out what the y value is of that hole, I'm going to take the remaining factor, the leftover factor, and I'm going to substitute my x value in for the x value of that remaining factor. So y is going to be 2 plus 2, so the y value of that hole will be 4. So then there's a hole at my x of 2 and my y of 4. How to determine if we have a hole in a function is to make sure that it's in factored form Once in factored form, if a factor in the numerator can cancel with a factor in the denominator, that shows us where the whole is at. We need to solve for x to determine the x value of that whole. To find the y value, we take that x value, plug it back into the remaining factor. So if I cancel those, what's left over is the x plus 2. And so then when x is 2, 2 plus 2, sorry about all the 2's, 2 plus 2 equals 4. So therefore I have a whole at the location x is 2 and y is 4.